we're asked to solve for s. And we have s squared minus 2s minus 35 is equal to 0. Now, if this is the first time that you've seen this type of what's essentially a quadratic equation, you might be tempted to try to solve for s using traditional algebraic means. But the best way to solve this, especially when it's explicitly equal to 0, is to factor the left-hand side and then think about the fact that those binomials that you factor into, that they have to be equal to 0. So let's just do that. So how can we factor this? We've seen it several ways. I'll show you kind of the standard way we've been doing it by grouping. And then there's a little bit of a shortcut when you have a 1 as a coefficient over here. So when you look at something, when you do something by grouping, when you factor by grouping, you think about two numbers whose sum is going to be equal to -2. So you think about two numbers whose sum, a plus b, is equal to -2, and whose product is going to be equal to -35. A times b is equal to -35. Since the product is a negative number, one has to be positive, one has to be negative. And so if you think about it, ones that are about 2 apart, you have 5 and -7. I think that'll work. 5 plus -7 is equal to -2. So to factor by grouping, you split this middle term into we can split this into let me write it this way. We have s squared, and then this middle term right here, I'll do it in pink. This middle term right there, I can write it as plus 5s minus 7s. And then we have the minus 35. And of course, all of that is equal to 0. Now, we call it factoring by grouping because we group it. So we can group these first two terms. And these first two terms, they have a common factor of s. So let's factor that out. You have s times s plus 5. That's the same thing as s squared plus 5s. Now, in these second two terms right here, you have a common factor of -7. So let's factor that out. So you have -7 times s plus 5. And of course, all of that is equal to 0. Now, we have two terms here where both of them have s plus 5 as a factor. Both of them have this s plus 5 as a factor. So we can factor that out. So let's do that. So you have s plus 5 times this s times this s right here. Right? S plus 5 times s would give you this term. And then you have minus that 7 right there. Minus that 7. I undistributed the s plus 5. And then this is going to be equal to 0. Now that we've factored it, we just have to think a little bit about what happens when you take the product of two numbers. I mean, s plus 5 is a number. S minus 7 is another number. And we're saying that the product of those two numbers is equal to 0. If I were told you that I had two numbers, if I told you that I had the numbers a times b and that they equal to 0, what do we know about either a or b or both of them? Well, at least one of them has to be equal to 0, or both of them have to be equal to 0. So the fact that this number times that number is equal to 0 tells us that either s plus 5 is equal to 0, or, and maybe both of them, or s minus 7 is equal to 0. Or, I'll do that in just green, or s minus 7 is equal to 0. And so you have these two equations. Actually, we could say and or. It could be or and either way. Both of them could be equal to 0. So let's see how we can solve for this. Well, we can just subtract 5 from both sides of this equation right there. And so you get, on the left-hand side, you have s is equal to -5. That is one solution to the equation. Or you have, let's see, you can add 7 to both sides of that equation. And you get s is equal to 7. So if s is equal to -5 or s is equal to 7, then we have satisfied this equation. We can even verify it. If you make s equal to -5, you have positive 25 plus 10, which is 35, minus 35. That does equal 0. If you have 7, 49 minus 14 minus 35 does equal 0. So we've solved for s. Now I mentioned there's an easier way to do it. And when you have something like this, where you have 1 as the leading coefficient, you don't have to do this two-step factoring. Let me just show you an example. If I just have x plus a times x plus b, what does that equal to? X times x is x squared. x times b is bx. A times x is plus ax. A times b is ab, plus ab. So you get x squared plus, these two can be added, plus a plus bx plus ab. And that's the pattern that we have right here. We have 1 as a leading coefficient here. We have 1 as a leading coefficient here. So once we have our two numbers that add up to -2, so once we have our two numbers that add up to -2, that's our a plus b, and we have our product that gets to -35, then we can straight just factor it into the product of those two things. So it'll be, or the product of the binomials where those will be the a's and the b's. So it'll be, so we figured out it's 5 and -7. 5 plus -7 is -2. 5 times -7 is -35. So we could have just straight factored at this point 2, well, actually, this was the case of s. So we could have factored it straight to the case of s plus 5 times s minus 7. We could have done that straight away, and we've gotten to that right there. And of course, that whole thing was equal to 0. So that would have been a little bit of a shortcut, but factoring by grouping will, it's a completely appropriate way to do it as well.